proceed our first opening high-level panel session with the topic of AI technologies and impacts for network ecosystem. And for this session, it's also conducted by our moderator, Ms. Jo-Fen Yu, our CEO of TWNIC. And also, we would like to welcome the following speakers to join our discussion, who are the Shing, the Vice President of CTO's Office, Taiwan Mobile. Welcome. Yes, let's give her a warm welcome. Welcome. Next, let's welcome Professor and Dean College of Artificial Intelligence, National Ming Chiao, Tung University, who is going to join us online, Ren-Hung Hwang. Next, let's welcome the enterprise architect, Akamai Shishio, Tsuchiya's SE lead chief engineer, Ms. Alex Leung, to join us. And now, without further ado, I'll leave my control to our moderator, Ms. Jo-Fen Yu. Thank you. Please.
Okay, thank you. So now we start our first section. It's talking about the AI and its impact on the network ecosystems. So everyone knows that AI brings a lot of impact in many areas. It's also in the network as well. So with this development of the AI, so the management and the utilization of network and IP resources have become more critical. So as we know, the intelligence network systems can improve the efficiency, strengthen the security protection, and also to promote the optimal allocation of resources. But we also know that it will raise the concerns as well, like the privacy, like the security, like resources fairness allocation. So this session, we will discuss in depth the application and challenges and opportunities of AI in network and IP resource management. And we will also explore how to use AI to promote the technology development while also we make sure that security and stability of the network ecosystem. Thank you. Today we will have really our wonderful panelists. We will have 4. 1 will join online and 3 will join here. So we are still waiting for another one, but he will join, really quickly. So we will have 3 from the industry and 1 from the academia. So the first one will be from the academia, Mr. Dr. Hwang Ren-Hung. He's a professor and the dean of College of Artificial Intelligence of National Ming Tung University. So he will join and share online. Our second panelist is Ms. Zhu Xiaoxing. She's a vice president of a CTO office of Taiwan Mobile. And the fourth one, we will have our guest from Japan, Mr. Shishio Tsuchiya. He's a lead engineer of Arista Network Japan. So we have also another panelist from Hong Kong. He's Alex Leung of Enterprise of Architect of Akamai. So, okay, maybe we start with Professor Hwang. Professor, can you hear us?
Oh, yes.
Okay.
Yes. Could you hear me?
Yes. Okay.
Okay. Thank you.
Okay. Professor Hwang, maybe I introduce Professor Hwang first.
Yes.
Yes. So Professor Hwang, he is a professor and dean of College of Artificial Intelligence of National Ming Tung University. So he received his PhD degree in computer science from the University of Massachusetts, US, and he joined the College of Artificial Intelligence, National Tung University in August 2022. And now he's a dean of the AI College. Before he joined the university, he also worked in the Department of Computer Science and Information Engineering at National Zhongzheng University. So he currently is an associate editor for IEEE, and also the work on the surveys and the IEEE transactions on vehicle technology, and IEICE trends on communications. Dr. Hwang published more than 260 international journal and conference papers. He's also a co-author of the textbook, Computer Networks, an open source approach with Dr. Leung and Fred Baker. So he received a lot of awards from the IEEE and also received the Best Paper Award from the 6th International Conference on Internet of Vehicles. So his current research interest is in deep learning, wireless communication, network security, AIoT, and cloud edge fog computing. And he's also a senior member of IEEE. So please, Dr. Hwang.
Thank you, Director. Good morning, ladies and gentlemen. It's my great honor to attend this plenary. I apologize that I'm not able to attend in person, so I need to present in this online session. But anyway, I would hope that the message I delivered could give some insights to this topic, the AI technologies and impact for network ecosystems. So I would just go through these 4 items, but primarily I would just talk about what are the current development of the internet, as well as the cellular networks, and then how AI come into this current or the future networks. And when we have these AI technologies in these networks, but we need to concern about the privacy and security of AI. So I will give an example of how this adversarial attack is very important, that we need to care about the trustworthy of AI. Okay, so around 2012, we know that several technologies was introduced into the internet. So from software-defined network and the network function virtualization, all the trend that try to change the internet from hardware-based to software-based, so that we are able to have more flexibility and more scalability, and more importantly, we can have better intelligent control over this network infrastructure. So, for example, for the network function virtualization, when we start to develop internet in this direction, we certainly can reduce costs, but and then we can have a rapid service deployment. But I think the most importantly that we are able to deploy innovative services in this kind of infrastructure. So when everything goes to software or to the virtualized, then I think it becomes better to manage them, and then we can have some kind of intelligent control. And in terms of intelligent control, then we know that currently AI would be a great help to do this kind of intelligent applications. So we can see that for the network function virtualization, the trend is going to AI-enabled NFV management and orchestration. So the traditional way to do manual is more rely on human expert, but right now the trend is that we will introduce AI into this area so that the manual could be done by AI technologies. So the same thing happened because when we want to deploy network function virtualization, we actually need the software-defined network as the infrastructure so that we can do like service change, routing, such kind of things. So the infrastructure also changed to software-defined networking. So the SDN combined with NFV has become the major trend for the infrastructure development. And again, for the software-defined network, either you use centralized controller or distributed controller. The controller actually needs a lot of intelligence. And when we need this kind of intelligence, again, the AI technology is a good candidate to help to do this kind of intelligent control, intelligent management. So as a conclusion of this development of this internet, the SDN and NFV as the change of the internet infrastructure. Actually, we will see that in the future as the concept delivered by Hwang, the author of the paper, the platform will become intelligent. So we actually will have machine learning or the artificial intelligence in our control platform as well as in our application layer, so that either your control or your application will utilize the AI so that they can do the intelligent part. So this figure shows that when we have this current infrastructure, we are able to we are expecting that the AI actually will come into the control plane as well as the application plane, so that the AI could be utilized in its great advantage. Besides the internet, when we look at the future cellular network or the 6G network, the ITU just approved the vision of 6G. As you can see that one of the vision is to integrate AI with communication. And if we look at the capacities of the IMT 2030, again, for the 6G networks, the AI-enabled capability is one of the major capabilities of the 6G network. So from the standard party point of view, AI is also an enabling technology for future cellular networks. And for the cellular networks, in the core network, we certainly will need the help of AI. But most of the cellular network rely on the success of the radio access network. And right now, the ORAN is the most popular architecture for the radio access network. And in the ORAN development, again, AI was AI is one of the components in the RIC architecture, especially for this kind of real-time applications. And for real-time applications, maybe the application of AI may not be fast enough to respond to this kind of real-time applications. But on the other hand, in the resource allocation plan or scheduling plan, we are still able to deploy the AI mechanism to help the intelligent control of the ORAN. So even from the radio access network, there's a component that is reserved for the AI technology. So another point of view from AI RAN Alliance is that we can use AI and RAN together for the infrastructure, and we also can use AI on RAN for the new applications, and we also can use AI for RAN for the special efficiency like resource management. So from different parties' view, we can also see that AI is coming into the radio access network. And even further, when we talk about 6G, there's a new concept of semantic communication. So in the semantic communication, we actually try to use AI to help the communication so that the bytes or the bits that you transmit may not be the original image, text, or voice. It could be just some features extracted from the AI model. That is, in the future, when we want to transmit an image, we may not transmit the whole image, but just transmit some features of the image. So what are the features of the image? It's just the representation after some AI models, or sometimes we call it legend code. But anyway, this kind of representations actually represents the semantic of the original image. So when we talk about image to text or text to image, we all use this kind of technology. That is to use some kind of representation that actually represent different objects, different format. So like we have this representation for an image, also a representation for a text, but in the representation in the written code, there could be semantically similar, so that we actually can do this kind of transform from image to text, transform from text to image, and all these kind of things could be done in this way. So semantic communication becomes a new communication technology that is enabled by the AI technology. Okay, so in our one of our papers, we discussed the concept of using AI as a service in the future network. So you can launch an AI service either on the fog, on the edge, or on the cloud, to make sure that it's available everywhere in the network. And there are some AI researches in the IP address management, the traditional IP address management. And I think I will just leave the slides here because I think I'm running out of time. But I want to deliver some important issues. The AI is applied in cybersecurity a lot recently. For example, the Google's AI-based phishing link checker actually use AI to check whether an URL you are going to is a phishing website. So there are many cybersecurity that use AI technologies to help humans to do better cybersecurity defense, like AI-based malware detection, AI-based intrusion detection systems. So the last issue I want to point out is that the privacy and security are important in developing AI, because there are lots of adversarial attacks that could happen to the AI models. Like lots of ways, like invasion, white box adversarial attacks, poisoning, backdoors, all kinds of cybersecurity threats could be found in the AI models also. So it's important to know that AI actually is facing this kind of adversarial attacks. So I would like to conclude my talk with this example. In this example, we actually develop an IDS system based on the vision transformer. So that's the newest technology in AI models. And we actually can develop a very good defense intrusion detection systems, like we can achieve higher than 99% F1 score for the popular data sets such as CICIDS 2017, 2018. But however, we can use special designed GAN with special designed loss functions. And guess what? We are able to change the malicious traffic into benign traffic for the IDS. So the IDS will misjudge this kind of attacks as benign traffic and let this kind of traffic pass. So it will fail to recognize that these are malicious flaws. So this figure shows that we are able to deceive the IDS system such that malicious traffic becomes malicious. The malicious traffic becomes benign traffic for these IDS systems. The same thing for both data sets. And we verify that by using tools like Wireshark to show that the disturbed packets are still legal packets. And we use TCP request to show that they have the same malicious effects, even they can pass the IDS inspection. So this example just shows that it's possible that we can have we can launch the adversarial attacks on AI models and to achieve the purpose that we want. So it's important that we know that when we deploy AI models, we need to focus more on the trustworthy AI models. So in conclusion, I think I have talked about it's the area of AI-enabled networking communication is coming, and there's a significant improvement in resource management, network function, intrusion detection, and so on. There are lots of areas that actually introduce AI to show that they have great performance. But the last thing that I point out is that trustworthy AI is important. Okay, I think I would stop here because of the time limit. Thank you for your listening, and I hope I can join the discussion later.
Okay. Thank you very much, Professor Hwang, for your wonderful sharing about the application of AI in networks and also the potential risks and concerns. So maybe the next panelist we will invite Miss Chu. Yeah, do you have the 简报笔? Okay. Okay. Ms. Chu is a vice president of a CTO office of Taiwan Mobile. She received his bachelor in W of National Taiwan University and also received a master degree in communication management of University of South California. And she also has an MBA from the National Tung University and also the EMBA from the National Taiwan University. So she has been working in the telco industry for a long time. So we welcome your sharing. Thank you.
Good morning. Today, I'm going to present more on the business side instead of technology. So to talk about AI that opens all kinds of possibility in the business sector. Okay, what I'm going to cover is why AI, how we use AI in Taiwan Mobile, and what is our view about the next development in the telecommunication sector. First of all, why AI? I think this question is the basic question if any corporate wants to launch practically in your department by department, division by division application of using AI. So to begin with, I think every company needs to answer this 6 questions before you started to do any AI plans or roadmaps or visions in your corporate. The first one is that is the goal. The question is, what do you want to achieve by leveraging AI? Many companies did not, know how to what they want to receive in business-wise or company-wise, whether it's the efficiency or your business revenue upsides, or your cost reduction areas. So this must be first to define very clearly what do you want by leveraging AI. The number 2 question is that, do you have a business roadmap or a company roadmap based on AI? If you do not have, that means you are doing it by just following the technology hype. And normally you're going to fail in launching AI very effectively. Number 3 is, do you have an AI-based organization? Which department will lead and which department will support in the roles of developing AI in your corporate? Number 4 is the most important part. I think most of the company fails a lot in this area, is that whether you have full attention and full control of where the data source is. And most likely all these data are from different sources. So you need to aggregate them and process them very carefully before you actually know how to use the data and form the pattern or the model and how you really do it in your real life application. The number 5 question is the technology. There's a lot of AI technology nowadays. So what are the technologies that you're gonna adopt first and second, and then so on and so forth. And number 6 is that whether did you prepare how much you're gonna invest? Because it requests a lot of CAPEX and a lot of OPEX in doing so. So what is your high level or your corporate commitment in investment? So this may come to your board and your CEO about this question. If you are not ready for the 6th question, actually, I think most of the corporate, I really urge you, you will not really know how to use AI in your daily operation. Okay, So my tips to begin is that you need to prioritize. So if to begin launching AI applications or leveraging AI technology into your daily business operation, the first thing is to prioritize. So look for the places where most data is, because it all begins with data. Without data, there's no AI at all. So, so if we divide it into two dimensions, you need to prioritize by whether your decision type is a burst decision or a frequently made decision and it repeat every month, every day. If it's a burst decision, it's very time critical. Actually, from my point of view, you just use rule-based or sometimes human judgment because it's very, very urgent and you need to make the decision right away. For AI to operate very well is that you need to look for areas that the most data is. Number two, you need to look for areas that's repeatable patterns. So like us, there are like customer services or like manufacturing industries, that's production scheduling. Or for all corporates, that's power saving missions that you need to achieve. And this is not a one-time shot. You need to repeat it every month, or you need to repeat it in certain cycles. So this are the areas that you are looking for long-term accuracy, meaning that this accuracy is something that you are looking for to improve over time, and you can tolerate the inaccuracy today, and you are looking for a very long-term improvement over time to get it to very, very precise. So these are the areas you can prioritize. Talk about long tail accuracy. I'll give you some examples of how we do it in Taiwan Mobile. First of all, from your daily division to division operation, there are a lot of automations that need to be done. So this is the beginning step. The automation may happen task by task, and it's sometimes very, very siloed by functions that need to do this automation by their own KPI or by their own objective. So it doesn't matter as long as you begin to automate in your corporate. And the second of all is you need to aggregate all this automation from all systems, the data. You need to dig it out and then put into some place where there is a centralized database. So this data may come from a lot of systems, a lot of automation processes. And then you need to do the processing and to make it very structural that you can use for training the machines, or you can use to do data mining or to do rule-based, all based on this data. So the second step I will call it as a big data transformation processing stage. And then you can use AI technology, whether it's machine learning or deep learning, to use all this data to make it into a very deepening or widening horizontal applications. So I'm going to show 3 cases later on how we use it actually in Taiwan Mobile. So to conclude is where is the long tail accuracy happens, and the places where the stakes are very high, then these are the places that you're gonna use AI from the beginning to help your operation efficiency and effectiveness. Okay, the first case that I'm gonna show today how we use AI in Taiwan Mobile is actually we are a telco. So we have fixed network, mobile network, and a lot of radio access network today use a lot of base stations. So from our company, we have about 33.5 thousands of base stations, including 5 frequency in the 4G sector and the 2 frequency we use for launching 5G services. And then we have a lot of fans and a lot of air conditioning type of equipment in our cell site. So the power we use today is very, very big. It's about like we have almost need to consume quite a lot of energy today. So how are we going to save the power that used by so many cells? Is a big problem for us. This is not only a ESG problem, it's also a cost problem. Today we have almost like $4 billion per year Taiwanese dollars pay for on the power side, to including normal power, and some of it are coming from the green power. So previously we kind of look at the throughput that aggregated from the whole network to a specific point of time that we turn off the conditioning because the throughput aggregated is not so high. So basically we do it previously as by manual setting. So a certain time we start to turn off all the air cons and the fans area by area in our network. But today, by using AI, we actually train this system to use previous training material from the performance index and some alarm and the records, because we do not want the temperature to go too high. It will cause quite a lot of problem, and it will raise outage in our sites. So today this is all controlled by AI, and it learn time over time to how to set the maximum throughput and what time to turn it on and off. And it's all roll out in our 33.5 base stations. So this is the case that we use for power saving. And the number 2 I'm going to share with you is about the network management part, because we have so many base stations, and each base station, they may have 3 sectors. They are doing all this radio frequency from different dimensions. And we have a lot of baseband equipments and batteries. So how we gonna manage the network management if one of the equipments or elements fail? Then we need to alert. And then we're gonna send operation people, maintenance people to the site, or if we cannot do it remotely. So the alarm system in our network management is a day-to-day very important task. Previously, again, we do it by manual, meaning that from our experience and records and those index that we can gain from all the systems, then based on previous threshold, which threshold would put this system into a very dangerous alert, then we set that as an alarm threshold. Today we do it by machine learning that we have. You can see from the chart that the orange part of the threshold are actually set by AI, meaning that it will project with some confidence level from the lower part to the upper part. And then they will set where is the threshold that they need to put alarm into the system, and let the network management team to look at this alarm and whether to do it remotely or to send people to the site to actually remove this alert. Okay, this is an example that KPI is setting by engineer, and so it's quite static. And from time to time, we'll review which is the threshold that we need to send out the alarm and the alert by different level of people. This is the previous one. It's all done by manual and reviewed by manual. Today, this is what we're using machine learning and AI technology in. Today, the KPI and the alarm borders are actually set by AI, and it will learn over time which is the perfect or near perfect alarm borders and the threshold that we need to send out in our network management system. So this is a number 2 case that I'm going to share. And the number 3 case I'm going to share is the AI-assisted customer service part. Today, per month, we got about 6 million user queries into our customer service. And we have 24/7 online customer agent to service all our near 10 million customers. And the representative we have today is near 1,500 people. And we have a lot of channels for these queries from the website, from calling in, from APP, from FB, and from Instagram. And most of all this is the split of these 6 million queries. So today we have chatbots. It's called Little Mind. And today it handles all the channels very proactively. So it takes over like 2/3 of the queries today. It's all handled by chatbot instead of human representatives. So we divide all these queries into a daily basis. So our Little Mind will handle like 13.3 thousand queries today. And out of this 13.3 queries today, there's only 0.8% of the question cannot be handled by the chatbot. It will then transfer back to live agent. However, still we are improving by using AI-assisted optimization system, meaning that when user they come to us with our chatbot with questions that the chatbot need to answer. If the reliability after calculation is very high, then we will just give the answer back to the user directly. But if the system calculate the reliability is not very high under a specific threshold, we will send back into the optimization system. And there are vectorized embedded model, and then we're going to match the vector set in our system. And we provide new prompts to the LLM system, and it will create a new response. And then we will calculate the reliability again, and then feedback to the upfront unit. If the reliability is very low, then we send this into human judgment. And then the human judgment will then revise or refine the answer by human knowledge. And then we put it into the knowledge base again. And all this kind of end-to-end loop is something our system do it every day. Okay, by doing so, remember that out of the 6 million queries per month, 4 million already are handled by our Little Mind chatbot today. And out of these 0.8% of the question that is transferred to human agent again, then with all this optimization today, we got 25% transfer back to agent, and it will further can handle 65% of the question by using the LLM or RAG optimized model. So by using all this, the knowledge base today on a yearly basis, we improve quite a lot, like 10% more into the question base or the question set. And altogether today, our Little Mind can bring our company to a accuracy of the Q&A to 98%. And the satisfaction rate from our customer on the survey is up to 95%. So this is the customer side using AI to optimize all the Q&A and our chatbot system. And going forward, we're gonna launch quite a lot of extended chatbot. It's going to be a listening and speech instead of the text part. So there's quite a lot of speech to text or voice recognition gonna launch later on. And we're gonna improve our LLM by using more powerful natural language processing and more powerful industry variables and industry domain names, meaning that there's quite a lot of vocabulary that's industry specific that cannot be handled by all these open source LLM. We need to be very corporate specific, very industry specific in the natural language processing part. So this is our roadmap about our AI assisted chatbot. And together we also using it to make it more easily for our agents is to make it into the identification verification using AI instead of asking quite a lot of questions for our agent to ask our customer to just to verify whether she or he is the actual person. We are going to launch it by AI assisted. And then there's quite a lot of customer service backend quality check. And by using AI, it will come up with very automatically quality index and quality service KPIs that can set to manage all this 1,500 live agents. So this will help us quite a lot in reduction of human representative headcounts and all so forth and so on. Okay, the last part I'm gonna end what's next. My very truly sincere advice is still that each company, you have your own homework to do. How you're gonna use AI in your corporate is quite different from another one. So this 6th question is very, very important. It's the beginning of my presentation, and I'm gonna end it here also. And the last of my slide is that Taiwan Mobile not only serve the consumer sector in our business of all the telecom services. Today, we also have corporate services that leverage all the experience and all the technology we actually use from day-to-day basis. So we have the telco plus technology efficiency or proficiency to support all kinds of vertical sectors to engage and empower in AI. And most importantly, I think, is help them to earn. So we do a lot of system integration using the technology we use and actually pragmatically deploy in our corporate and integrate and customize to all kind of corporate customers we have today to help them to do cost reduction or revenue upsides. And that ends my presentation today. Thank you.
Thank you, Mr. Chu. Thank you for your great sharing about Taiwan Mobile's journey to deploy the AI in various areas, not the network, but also the client service. And also I mean, it's really important, I mean, the tips, I mean, for, how to successfully deploy the AI in the business. Thank you. So now we welcome our third panelist, Alex Leung. Ms. Leung is now in Akamai, is a senior engineer architect. So he serves as a trusted advisor for the leading broadcasters, helping them to transform their services to adapt to the OTT, the delivery trend, and navigate the complex world of technologies. So at Akamai, he also led a media consultancy project that helped regional broadcasters optimize their media streaming operations in preparation for large events, including the Winter Olympics and the IPL 2018. Please.
Thank you. Good morning, everyone, again. Hi, the title of my presentation is called Cybersecurity Challenge in the Age of AI. Great. So AI has been getting a lot of popularity in the past 3 years. However, let's take a short look at the historical progression of it. The term AI was coined in 1956 in a Dartmouth summer research project organized by John McCarthy. And he invited several leading mathematicians and computer pioneers to Dartmouth College and had a summer research project, and that was in 1956. And if we do the math, it's been a academic research subject for a little bit less than 70 years. And over the years, we've seen progression from machine learning, neural networks, and in the past decade with the transformers and attention, and leading to the explosive application of generative AI. So if you look at Google Trends, you can see there's been quite a sudden peak coming up near November 2022. That was the public launch of ChatGPT. And since then, it's been getting a lot of attention in many fields. And cybersecurity is definitely one field that's been actively impacted by AI. Why do we say that? I would say the cybersecurity field, in the Star Wars terminology, both the Jedi side and the dark side are heavily learning about AI and exploring its implications. Now here is the Darth Vader side of using it, and you can see the dark side can ask ChatGPT with malicious intent. Now, of course, there will be guardrails in ChatGPT saying you are not supposed to learn how to build explosives, and you are not supposed to do hacking into the bank's database, right? So I'm not sure if you have been naughty enough to ask ChatGPT how can I exploit this SQL Server, CVE, certain, and that, and then the guardrail will say, oh, hacking might be an illegal activity, and you're not supposed to do that. But there are lots of ways to trick around it, and this is one way to ask for a sample DDoS script, and you can just pretend to be naive, pretend to be non-harmful, and ask for a Python script that can make a request for 1,000 per minute. And then once you got the sample code, then you can really fire it up and go up to like 1,000 per second. And we are also seeing some synthetic identity fraud. This is AI-generated deepfakes. And you can Google about one of the CNN news. Somebody deepfake the CEO's voice and then fool the financial controller. And then at the end, the organization, the victim organization lost 25 million. So, so I've actually invited President Joe Biden to give us a short cheer up in this morning. Hopefully the play button will work.
People say I am the Sleepy Joe, but I think it is often the security team that is sleeping, and the attackers are taking full advantage of their lack of vigilance.
Right. So some people call President Biden Sleepy Joe. I certainly disagree with that. And he's coming here to wake us up. And I think we should no longer be sleepy about the threat and the opportunity of AI. So let's talk about Akamai's AI journey. We have been tackling with some of the most challenging cybersecurity problems in the internet scale. So we had to use machine learning. We had to use AI. A lot of the cybersecurity problems, let's take the example of discerning an HTTP request, right? When a HTTP request hit an Akamai Edge server, then we need to do the discernment, right? Is it an request originating from a attacker script empowered by generative AI? Is it from a botnet? Is it from a hijacked smart TV that's been controlled by criminals and sending the request over? Or is it a non-toxic, perfectly healthy request from a real human? Or in the case of real human, is it the right human, right? I am the owner of my bank account, so if I issue a HTTPS request to log into my bank account details, then I'm the right human. But if it's some criminals from another continent, then he or she is not the right human. So all this needs to be discerned, and then from the discernment, then we can make the right decisions. And because it's a problem in the internet scale, we cannot fly a remote island in the Philippines and then hire a human to inspect and then go through every single request and then report the decision back to the headquarters. It doesn't work that way. So machine learning has always been in the very much DNA of Akamai. And here's a short history of it. So there are many ways we need to learn through machine. So to make today's presentation a little bit more tangible and less abstract, I have picked one machine learning classification problem and share with you some of its details. The project is called ARCANET. We all know NET is network address translation. Is heavily used in organization or university campuses that the organization will be fronting its internet facing with one single IP. And then behind the net, there will be some private IP addresses serving maybe students in the university campus or the corporate staff behind a corporate network. So in this regard, so every IP address can be classified into two categories. One is called shared, that is fronting the NAT, serving many people behind the corporate networks. And the other nature is called unshared, meaning the IP address is solely owned by that user for that period of time and is not shared with other users. So in this diagram, the gentleman on the left-hand side of the planet Earth is representing an unshared scenario, while on the right-hand side you can certainly see the NAT gateway, and that's the shared scenario. So we have a classification problem. We need to build machine learning model so that we can discern whether this given IP is shared or unshared. And the challenge, why does it make business sense, and why is it valuable in the business perspective to ascertaining an IP as shared or unshared? Well, we all want to avoid false positives, right, in the cybersecurity battle. If you wrongly blacklist a shared IP address, what will happen? Legitimate traffic behind the net can also be blocked, right? So in the worst case, you could be blocking everyone from a university campus. Now, number two, because of the shared nature, so you can expect the request rates from behind the net should be higher, generally speaking, compared to the case of unshared IP, because there could be many actors behind the net. So you want to have different threshold depending on whether the IP is shared or unshared. So the challenge is not unlike the neural network for doing a binary classification. So like discerning whether this photo is the photo of a cat or whether this photo is a photo of a dog. And you can see this neural network has been well trained. The probability of confirming this picture is a picture of dog is 0.98. So it's quite nice. So, so our goal, to reiterate, is when an IP address, say 6.5.4.3, hitting the Akamai Edge network, we want to have a model that's well trained, and then it can discern, hey, this IP address is of the shared nature, and let's devise all the proper cybersecurity defense measures by taking into account that this is a shared IP and not an unshared one. So now to begin with the training, just like the former speaker, it starts with the right data. So we need labeled training samples. So for those of you who's been practicing AI, this is the form of supervised training. So we need accurate, large volume of labeled data that's been labeled correctly with the correct answer. And in our case, what are our training samples? Here in Akamai, we are blessed with a vast amount of data, highly accurate and real-world data from the internet, so we can label them according to the IP address and the nature. And now once we collect enough training samples, for each IP address, we want to generate their fingerprint. This is part of the feature engineering. Like, what's the profile of this IP address? For example, this IP address could have certain request count, certain number of unique user agents in its request. So all these HTTPS request headers, the patterns, we will do the calculation and do the investigation, and so that look at all the headers, the order of the headers, the TLS fingerprints. So all this will form the profile of the IP address. Just like in the case of cats and dogs photos, the sharpness of the ears of the animal and the shape of its nose, all these are the feature engineering if you were to conduct a AI project for differentiating cats and dogs. Now, now it's time to feed the label sample into the model and adjust the weight so that through the iterations, your model will become better and better. So in other words, tuning of the array of weights is just a mechanism to make the model prediction better and better and in closer alignment with the labeled sample data. And here we, for this project, we employ an open source project called XGBoost, and we use it combining with our label data and do the training and achieve the trained model. So, and it's also important not to devote 100% of your label sample into the training, because you want to keep like maybe 20% of it just to test the quality of your model, right? If you give your model all the model answers, then you lose the opportunity to have some reserved sample to test how good it can perform. So finally, this is the result. We did a trial run, and we noticed one customer is opening a new office, and then that's definitely a shared IP. And then through the model, it can successfully discern it is a shared IP address automatically with no human intervention in 12 hours. And this compared to had we not performed this ARCANET project, it will take many days to arrive at the same conclusion. So in conclusion, we have shared one facet of how Akamai analyzed the incoming HTTPS request and use machine learning to do the discernment on the incoming request. And I would like to invite, particularly for the audience, if you have a lot of cats and dogs photos, you can go download a copy of the XGBoost and start doing your AI-based discernment. Thank you.
Thank you, Mr. Leung. Thank you for your sharing very interesting and a very detailed experience about how to use the machine learning to classify the IP addresses. Thank you. So our final panelist is from Japan. It's Mr. Shishio Tsuchiya. He started as a network support engineer at Ricoh, and also he worked in Cisco as a consulting system engineer from 2000 to 2016. He has over 20 years experience on networking, maintenance, design, and consulting. So he's also contribute to industry community like IETF, APAC-TWNIC, JNOC, and also so on. He has established software working group of JNOC. He worked as a chair from 2012 to 2013. He also received the MPLS Japan Award 2012. He joined Arista from 2017, and he's working currently supporting a lot of service providers and data center network. So please.
Thank you. Thank you for the introduction. Yeah, this is, she explained this slide, so I will skip this slide. Before I presentation, I like to explain the Arista networks. Arista is my company, and Arista is a United States company, but it is not. It is still a small company compared with our competitor. So I'd like to explain this slide at first. Arista is a data center switch equipment vendor, and which use merchant silicon chip. Andy Bechtolsheim and Ken Dude and David founded Arista in 2004. Andy is founder of Sun Microsystems and Granite Systems, which was a startup company of a gigabit Ethernet switch. And the company acquired by the Cisco 1996. And he found Arista to achieve Moore's law for networking. And he also known as a first investor of Google. And Arista launched the first product in the 2008, and we takes 4 years to develop a carrier-grade, cloud-grade operation system software. And our software, operation software name is Extensible Operation System, which runs on the user space of unmodified Linux with merchant silicon chip, like a Broadcom, DNX, and XGS programmable ASIC, like a Barefoot, and the FPGA, and x86 CPU by the single binary image. And our stock is over the $200 US dollar, and our revenue is $5 billion in the last year. The network traffic volume of data center drastic increasing by the AI machine learning communication. So who require the AI ML? This is in, who requires the AI ML? This is industry and application. For example, enterprise application is customer support and document creation and automatization. And manufacturing, quality control, predictive maintenance, and healthcare, diagnostic support, document analysis. Finance, predictive analysis and credit scoring, web gaming, content create, and customized experience. Retail, revenue analysis, demand forecast. Energy is improves energy efficient, predictive maintenance, transportation, logistics optimize, traffic forecast. Hwang is a corp management, pest prediction. Education is a private lesson, material created. So every industry needs AI ML. What is different about AI workload compared with normal computer workload? Most of AI workload use collective communication for parallel computation, and they use RDMA kernel bypass technology for better performance. Traffic characteristic is tight time synchronization between the traffic flow and a small number of large size flow until 2 flow panic and very little entropy and short periodic bursts of the network activity followed by the compute. And highly susceptible to the collision, and the slowest member determine the performance, which means job completion time. AI training workload are high coordinated and sensitive to the delayed job. IXM use RDMA, and RDMA is remote direct memory access. Most AI network traffic is GPU to GPU. Normal network packets are written, I'll explain the remote direct access. The most AI network traffic is GPU to GPU. Normal network packets are written to the kernel buffer and then copied by the CPU to an application buffer. The CPU becomes a major bottleneck. RDMA allows the application to directly read or write to another system's host, memory or GPU memory, avoiding the OS network stack and any CPU processing. This explains the importance of network I/O in the AI. Method Alexi explained time spending in network, each of models. For example, model 2, time spending over the 50%. So expensive GPU sleeping during the time, because this is not calculate any formula. So requirement of an AI network. At first, the lossless network hold many forms of communications, all reduce broadcast all to all. Graceful handling of the large synchronized flow and fast transfer from the host to network, RDMA, and the network support for it. Visibility and telemetry to identify the bottleneck in the network or application. And the reliability and resiliency required, and it should be open and interoperate. And AI workload require dedicated high-performance lossless network. So why Ethernet and why Arista and EOS? Ethernet because open, standard base, and it customer choice over silicon and the system and the optics vendor, and it is scalable and interoperability. And the technology you are familiar to the network operators, the easy to design, deploy, operate, and troubleshooting. Arista and EOS because AI need high bandwidth, 800 gig or 400 gig, 200 gig, 100 gig. And it requires lossless network. We have cell-based fabric, optimize load balancing traffic flow. And we have some QoS technology, ECN and PFC. ECN is notified the congestion to the end node. PFC is pause frame when the congestion. Pause frame to the sender adjacency when the congestion. And also adjusting buffer allocation scheme, handling the incast, TCP incast. And the scalability and managed tenancy, we have mature layer 2, layer 3 feature. We have VXLAN and EVPN. And the network visibility, we have extensible account, and we have a real-time set streaming. This is merchant single chip switch silicon through the 2025. We currently major switching chip is a 7 nanometer semiconductor processor technology, and we release 5 nanometer technology in this year, and also we expected it to 3 nanometer technology after the 2025. And this is bandwidth shipped by the switch silicon, the SerDes speed. SerDes means serialization, deserialization between the switching chip to the optics. And 100 SerDes ramping in the 2024 and dominating the bandwidth shipped in the 2025. And 200 gig SerDes ramping in the 2026. And so switching silicon density doubling every 2 years. Currently, our chip is a 7 nanometer processor. Switching chip density is doubling every 2 years. Currently, our switching chip uses a 7 nanometer processor, and it supports 400 gig optics. And the silicon is support 64 by the 400 gig in the single chip. And this year we'll release the 5 nanometer processor technology, which will support 800 gig optics. And also, the silicon is support 64 by the 800 gig in a single chip. And we expected 1.0 terabps optics by the using 3 nanometer processor technology. And the 64 by the 1.0 terabps support in a single chip in the 2026. This is a platform for the AI networking today. We have AI spine leaf, require the low latency and fixed system. And we have Broadcom released XGS family Tomahawk 4, which use 7 nanometer technology. And this product using a Tomahawk 4 in the single chip. And also AI spine. Broadcom has a DNX family and Jericho 2C. And the requirement is the high density and virtual output queuing and cell-based system. And Broadcom also released the fabric chip with a switching chip. And we constructed a modular-based system. We have a 7800R series, and which is supported 4-slot and 6T-slot. Yeah, this is a network design, non-blocking fabric for the AI network. AI leaf spine. Oversubscription is 1-to-1 or greater factor 3 that require more uplink than the total downlink. And 1-to-1.2 or higher is recommended considering the degree of the ECMP dispersion and the link failure. And various tuning over ECMP and QoS as applicable. And the transceiver cost need for the inter-switch link. And also some customer using AI spine and by the modular system. It is a very simple design and the fabric and designed with N+1 and needed to consider cabling design based on distance to node. I explained the AI application and design in detail. And the small AI application scale is 64 by the 400 or 128 by the 200 giga GPU. And then we recommend Tomahawk-based system. And it has no flow collision because a single ASIC. And in case and at the receiver, ECN or PFC to handle ingress. And Tomahawk is a low buffer, so require moderated buffer tuning. Moderate AI application. The scale is 576 by the 400 giga GPU. We recommend a modular-based system, which modular-based Jericho system, 7800R3, which use Jericho 2C chip. And the leaf spine in the single chassis, and no follow collision between the line card and the fabric, because cell-based forwarding. And high availability, fabric, Hwang, and the power supply, and the supervisor redundancy. And built in the over provision between the line card and the fabric. Incase and the receiver, ECN and the PFC to handle incase. But Jericho chip has over the 4 gigabyte buffer, so deep buffer require minimum queuing tuning. And I'd like to explain the cell switching in the 7800. High non-blocking bandwidth and collision-free schedule service fabric. 100% fair and efficient load balancing. And over-provisioned fabric capacity. Advantage over two-tiered Tomahawk 4 design. And ECN and PFC handle incast deep buffers require the minimum tuning. And this is a large, this is a large AI application. Scale is this scale 18432 by the 400 GPU. And the leaf is a Tomahawk-based system, and the spine is Jericho-based modular system. For collision between the AI ML leaf and the spine, optimal load balancing de-elevate source interface-based load balancing. They will require the minimum tuning. And the link failure between the AI ML leaf and the spine required 1 to 1.2 over provisioning on leaf. Incas at the receiver, ECN and the PFC 200 TCP incas. The low buffer require extensible tuning. AI network requires telemetry, and we have a streaming telemetry. This is our software, our EOS software, and the EOS has a NetDB, which has a state machine on the network. And direct connected to EOS SysDB, we have an application of Tamiatar, and which is direct connected to EOS SysDB. Present the as-is state of the switch in the millisec, or less over the tree structure or streaming event. Streaming update if there is a change in case, change in status, or a SysDB state, and all of smash table, like a routing table, up table, and the MAC address table. And processing the kernel data, such as CPU and memory usage, and the system log message. The collector, we have some collector, telemetry collector, which called the Cloud Vision, our software tool. And the visibility and the telemetry is important for the AI network because we have to monitor the buffer status. And ECN and PFC status and monitoring important for the tuning. This is the conclusion slide. AI useful for the whole of industry, and high bandwidth require the connection to the GPU and inter-GPU communication. The Ethernet and the merchant silicon has economical merit for the constructed AI fabric. AI fabric requires some traffic management technique like enhanced ECMP and PFC ECN. And visibility telemetry important to analysis job complete time and easy troubleshooting in the fabric side. I explained I'm not explaining the detailed technical information in this slide. If you interested in the detailed technique of QoS or RDMA or PFC, then please check this reference. My presentation ended. Thank you for your attention.
Thank you very much, Mr. Tsuchiya. Thank you for your really detailed explanation from the technical perspective about the requirement for the AI network and also the features and applications, of the AI networks. So maybe now we open to the floor to the audience. If you have any question, please stand in front of the microphone. Okay. So maybe, may I have this privilege then, maybe to ask each panelist one question. So Professor Hwang, you still online? Okay. So
Yes.
Okay. So for Professor Hwang, so my question is for you is that, so we know that AI have really been, developed for a long time. But now we start to see a more and more application and use. So when do you see the AI will be widely deployed in IP networks? So it's a question for you. And for our question for the second panelist is that, thank you for sharing a lot of challenges and also the tips. But what is the most biggest challenge you see when the companies or your clients, I mean, when they deploy the AI, what is the biggest challenge for them? And for the third, Mr. Leung, is that you mentioned that the machine learning, but we also know the machine learning, sometimes there's a, there's a good thing and bad thing, I mean, due to the process. So when you develop the product or services, how you navigate or how you to mitigate, I mean, the risk, but also maximize, I mean, the benefit. And for the Tsuchiya-san, what is the most important feature for the AI network? So, okay. So maybe we started from the Professor Hwang.
Okay. I think it's already deployed in many products, as I mentioned. Mostly current cybersecurity products has been adopted AI in the framework. And for others, I think the 6G networks certainly will also have the AI element or component in their architecture. So to widely deployed AI in internet and in cellular network, I would expect that it's going to happen within 3 to 5 years.
Okay, thank you. So maybe we have Mr. Chu to share.
I think the most difficult part or the most challenging part in deploying AI in our case or the cases of our clients is the main purpose of adopting AI is that you are looking for something to improve in your business operation. That means you are looking for methods to improve the efficiency of human operation or judgment. Okay, so the most important part actually I find is that where are the causes of inaccuracy comes from. So normally there's a lot of question in your model. So there may be a modeling problem, there may be data quality problem, and sometimes it's the AI looping problem, and most importantly, I think it comes from the business issue. So the inaccuracy of your AI modeling or your machine learning modeling may come from these 4 areas. And the most difficult part to improve, I think, mostly come from the business issue itself. Not the data, not the model, not the AI. So you need to understand there may be regulation limitations, operation limitations, human and your system co-work issues. All these kind of issue will end up with inaccuracy coming up from your AI-assisted systems or business operation. This is the first part. And the second part, I think, comes from the organization culture and resistance of deploying AI. Because today there's more about, I can see all the cases is all about substitute effect instead of creation effect. I actually did not see any creation effect in launching AI-assisted business process, meaning that is to substitute something instead of creating something. So that's why today AI is not a very, how to say, revolutionary technology like electricity or other kinds of technology we used to have in the past. In order for AI to become a real revolutionary driving force of all industrial application, I think it needs to find creation value instead of substitute value. Today, I can see more on the substitution side. So when it comes to substitution, the resistance from the organization is quite high because people are quite afraid or they are not really appreciate the AI assistant part in your organization. So we need to find how to use AI to replace the task today and not replace jobs. So this is the resistant part I can see when we are deploying AI-assisted business process. So this is something I need to share, two parts. Yeah.
Thank you. So maybe now we have Ms. Leung.
Right. So the question is, what if AI went wrong? And what if some of the inaccuracy in the AI model is manifesting itself in a way that may harm our business objective? So it is a very important question to ponder, and it has many implications in the philosophical domain and also in the national education domain. Maybe I can share one example that in ChatGPT that you can sometimes experience hallucination of the generative AI. So there's a take-home exercise you can try. You can ask ChatGPT, who is Tom Cruise's mother? Okay, and then ChatGPT would tell you Tom Cruise's mother is Mary Lee Pfeiffer, right? And then you can ask ChatGPT back, then who is the son of Mary Lee Pfeiffer? And then the bot went into hallucination and couldn't figure out. Well, the bot just answered it, right? By human reasoning, we know from the former dialogue that then it would mean Tom Cruise. But so this is one example. I think it has a lot of implication in the philosophical side and also the education side, because we, as a netizen, as global citizen, we have to become not just literate, but also AI literate, meaning we need to teach ourselves and also our children how to tell something is wrong in the application or in the manifestation of AI, and I think it's a very important technique moving forward. Now, on the application of it, like some observer would tend to be very fearful or worrisome about accuracy of the models. But I would like to point out one mathematician, I think it's George Pox. He once mentioned a very cruel fact. He said all models are indeed wrong, but some models are useful. So I think there's some truth in it. So like when we think about the application, maybe we can divide into two broad categories. One is life and death issues, like using AI in the medical domain, or maybe driving a school bus. That could be life and death matters, right? And then the other, like maybe giving a recommendation on what should be my next movie. in the search engine. That's certainly not as life-threatening. So maybe we can start more progress in the non-life and death category first. And for the life and death, I don't have a good answer for it. But looking back at the COVID-19, somehow we are already learning to live with imperfect models, right? The fact that we do the vaccine and also doing statistical inference from the effectiveness of the vaccine, and then we finally bite the bullet and then get our jab. So all these are putting our faith in some credible imperfect models, although it's not perfect and it's not 100% accurate, but we still believe to a point that we have our jab. So yeah, that's my input. Thank you.
Thank you. So maybe we also have Tsuchiya-san to share.
The question is what is most important network feature of the AI network for the network operators? And the answer is telemetry, for my opinion, because AI network required fast and loose network, and the communication, most of the communication is GPU to GPU. And the GPU communication depends on the type of communication. If the network cannot handle the traffic, then the expensive GPU will be asleep. So network operator have to identify bottleneck in the network or application. So I think most important network feature is telemetry for the AI network.
Thank you. Given the time, I think we will close the next section here. Thank you for all the great panelists. Let's give them a big applause now. And also thank you for your participation as well. Thank you.
Thank you all the past panelists for giving us such a wonderful conversation regarding AI technology.